Let's take a look at moving a C++ application from Intel x86 Linux to Power Linux. Here is a summary of both environments. Notice that both virtual machines are configured for one core, 16 gigabytes of memory, and are running the same release levels of software. This demonstration shows how easy it is to move a C++ application from Ubuntu Linux on Intel to Ubuntu Linux on Power 8. In addition, we'll take a look at the performance of the application before and after the move. The yellow terminal is connected to the Intel system. This command outputs how many logical processors are in the virtual machine. There are two logical processors or threads in a single Intel core, so this virtual machine uses one core. Now let's look at the Power 8 system. The green terminal is connected to the Power 8 virtual machine. The same command outputs 8 logical processors, which is the number of threads in a single Power 8 core. So both virtual machines use a single core and both have the same amount of memory. This is the IBM SDK for Linux on Power, which is a free Eclipse-based IDE. You are looking at a C++ application in the SDK running on the Intel system. What I'm going to do is compile and run this application. So first I'm going to build the project. That will compile the executable. And at the end we have the executable under binaries, which is called mcalc, and then I'm going to run this executable. This is a matrix multiplication application which multiplies two matrices of 1000 by 1000 together, and what it will do is it will time how long it takes to execute the application. As you can see, it took nearly 15 seconds to execute this application, and it also shows the value of the second row, second column in the resulting matrix. At this point, to move it over to Power 8, I would simply export the project into an archive and then import it onto the Power 8 system. This is the exact same IBM SDK for Linux on Power, which is now running on the Power 8 system. As you can see, I've already imported the same project from the Intel system, and I'm going to do the exact same thing, which is to build the project. In the binaries this time, you'll notice that the binary that was generated is now a PowerPC 64 version, and I'm going to run the exact same application. Matrix size is the same. I'll click multiply, and it will run the application. As you can see, this only took 2.4 seconds to complete. To remind you that this is significantly faster than the Intel runtime, let's go back to the Intel system and see that it ran in just under 15 seconds, whereas on Power 8, the same application just recompiled ran in 2.4 seconds. This graph summarizes our laboratory test results of varying the matrix size. As the matrix size increases, meaning that there are more double precision math calculations, the Power 8 performance advantage over Intel also increases. The 1000 by 1000 matrix size resulted in an execution time advantage for Power 8 over 6 times that of Intel. So not only is it very easy to move your C++ applications from Intel to Power 8, they also perform better.